In this question from the trigonometric identity, we can see we are given 1 plus tan square A plus 1 plus cot square A. We need to prove this is equal to tan square A. And similarly, 1 plus tan A over 1 minus cot A whole square should be proved as equal to tan square A. So let's say begin with the first part. Here I'm going to prove this as this. Now, what do we know here? That our LHS is in tan and cot, and we have to prove it is equal to tan. So I can see that I can, we have a direct relation between tan and cot, as you can see. Reciprocal of cot is tan. So this is what I'm going to proceed. I'm going to write tan square A as 1, cot square A as 1 plus tan square A. So this is 1 plus tan square A in the numerator is left. And I wrote this cot square A as 1 over tan square A. That's what I did here. This is the only change I made. I wrote this tan square A as 1 over cot square A, as tan square A is reciprocal of the other. Now, if I take LCM, I can see this is the numerator is 1 plus tan square A. And if I take LCM over here, the LCM is what? Tan square A. Tan square A multiplied by 1 is tan square A plus 1. So the equal to sign is over here. Now, what else we can do here in the next step? We can see that this is divided by this. So let's say this is 1 plus tan square A. You know that dividing is same as multiplying with the reciprocal. So I can multiply with the reciprocal of the denominator. And this is 1 plus tan square A or tan square A plus 1 is all same. As you know that addition is commutative. So this get cancelled, right? This get cancelled. And we get this is equal to tan square A. So we proved this part is equal to tan square A. Now in the next, we have to prove this using the same manner. This is what equal to this is what I'm going to prove in the next step. Let's say I do it here. Now this is what we have 1 minus tan A over 1 minus cot A whole square. So what I can do, I can the same way, I'm going to use that reciprocal. That is, I can write this cot A. As I said, this is cot A can be written as 1 by tan A. We need to keep in mind we have a whole square here. Now for the further simplification, I'm going to take LCM. Now if I take LCM in this may be same, like I can write 1 minus tan A as it is. And if I take LCM over here, is going to be what? Tan A minus 1 over tan A. And then we have a whole square here. This is something we have to keep in mind, because if I put square over the whole thing is different than putting a square over the numerator. Now this is what I can write this as 1 minus tan A as it is. And as I said, dividing is same as multiplying with the reciprocal. So I'm multiplying with tan A over tan A minus 1. And then this is square over it. Now check, this is, unlike the previous part, we cannot cancel this with one time. As you know that A subtraction is not commutative. So let's say this is 1 minus tan A, and we have this is tan A minus 1. We can cancel them by minus 1 time, right? They can be cancelled by minus 1 time. So we'll now get what? Minus tan A whole square. And as you know that the square of a negative number is positive, so that should give you tan square A. So let's figure out that we have proved here the LHS and the RHS as same. As you can see that the LHS and RHS are equal. This is C. So therefore, we say that all these two function is written in the as tan square A. So we say that this is how it can be proved.